So this is a great problem right here. So what we're doing right now in Integrated 3 is trigonometry. And I want to show you how I've been working with trigonometry over the last few days. So I have this dump trailer I bought for the wood shop, and it has this mini skid steer that parks on this front ramp here. Everybody with me? And the point of this is that I load this whole thing up. I drive out to where there is fuel reduction waste. I take the mini skid steer off of ramps that come down here. I grab the logs, I put them in the dump trailer. I drive the mini skid steer back up here and I park it. I drive it back to the high school. I unload the logs, and then we mill the logs into lumber and we make wood projects out of it. Okay? But watch, I have some video here of me loading this mini skid steer. So first, note the treads off the ground right there. Yeah. Note that gap right there.
That's scary.
That is scary.
Were you ready to jump off?
I was ready to jump off.
Good.
Boy, it gets scarier. Keep watching. Watch. Now look how high.
Don't just jump on it and it'll. There you go.
So this is me unloading it. Now watch my face here. Watch my face. You can just catch it. I'm going off the cliff is how I feel. Watch my face like this. So let's watch that one more time. Okay, everybody understand what's going on here? Okay.
There it is again.
So let me show you what's going on here. Here is the trailer bed that the mini skid steer is going to park on. Here are the ramps coming down. These are 6-foot ramps. It was nice level ground, right? And this is a 3-foot height. Everybody with me there? So what is my problem? What is the issue here? What? It's too steep, right? How steep is it? You know that triangle?
Oh, it's root something on the bottom, right?
Yeah, this is root 3 on the bottom. What's that angle right there? 30 degrees, right? So the current angle is 30 degrees. My real issue is as you extend this ramp this way, parallel lines cut by a transversal, this angle is 30 degrees as well. That's the angle that's scaring me. Everybody understand that? So how do I fix it? Oh no, that would be cool. An electric lift would be cool. But that mini skid steer is over a ton.
Oh, goodness.
Right, so you got, and part of the reason why I was on top going up is I figured I was going to get catapulted off and I might break my foot or something, but I didn't want that thing to fall on me. That would have been the end.
You didn't want to break it.
I don't want to break it either, but I really didn't want to break myself. Zach?
You should like taper the top of the box or whatever. And that would work.
What if you got yourself a longer ramp?
Well, so I did. I looked into a longer ramp.
It would decrease the angle.
Right, here's my platform. I called the manufacturer and asked them about an 8-foot ramp. So the question is, what does that change my angle to? Right, so what is that new angle?
Funny.
What are we doing right now in this class?
Trigonometry.
Trigonometry. What we're doing right now in this class is trigonometry. If I want to find the measure of that angle, this is the point of why we're learning this, is the sine of theta is equal to, what's it equal to, Zach? 3 over 8. Now I need to solve for theta. How do I get theta by itself, Elizabeth?
Multiply by arc sine.
Yeah, so I take the arc sine of 3/8. Do you just see that?
Yeah, I got. Yeah.
22.
Okay, So if I go to an 8-foot ramp, I go to an angle of 22. That does in fact decrease this angle, that tipping point, right? That's my scary spot right there, Kayla. My scary part is when that thing tips flat. So here's the problem with the 8-foot ramp. First, there's no place to store it. I got to modify that whole trailer to store that 8-foot ramp. The other thing as well is that this ramp is over 60 pounds and it's kind of a reach down. So when I go to that 8-foot ramp, if this is 60 pounds, this is going to be 80 pounds, which is getting up there. And as I create a larger span, I decrease the strength, right? So now it's not as rated as this one was rated for the same weight. So that's the downside. I do like the 22 degrees. Any other thoughts? That's it.
What if you got a fold-in?
Right? That's a great idea, right? So that this bed right here now has a pivot point. Like this is pivoted here, and I just have a jack right here. And I only have to lift this up a few inches, and it's going to decrease that angle by a lot. The other thought I had is actually keep the 6-foot ramp, take this ramp down, and put a block here. That's a steep, a block that the 6-foot ramp sits on, and build a really steep ramp here. And if I only come up a foot here, right, so this thing's a foot higher, this now becomes 2 feet. So now I'm going to find this angle, because that's going to be the same angle as that. You doing that? So do the arc sine of 2 over 6.
19.4.
19.4. So this is 19 degrees. So just by raising the bottom of this ramp a foot, I'm going to have a 19 degree angle versus going to an 8-foot ramp, I'll be at a 22 degree angle.
But how are you getting up onto the block?
But this block would be a ramp as well, and I wouldn't even mind if it was a steep ramp, because if I come off of this thing, my fall is less than a foot. This is the highest cost, so I really want to decrease that transition point. So my point with this is that we're studying trig right now in math class, and the whole reason we learn these things is so you can figure this stuff out. I mean, I could go out there and build an 8-foot ramp and measure it and test it, and I could try this. But the power of math is you could actually do a lot of thinking and figuring before you actually have to build anything, right? This is going to cost me a lot of money to build. It's going to take me a few days and hundreds of dollars of steel, and then it might not work, right? This takes 5-10 minutes on the whiteboard.